together. Thank you. Okay, so it has been 5 minutes, so I don't think we can wait for your friends any longer. Okay. Okay. So for today's session, we will try to solve problems try to find forces within the truss. So before we can do that, I would like to recap what you guys should have learned before this, because these points actually very important in the calculation later. Okay. So please take note that there are two ways to analyze the forces in the truss. The first one is the method of joints, and second one is the method of section. So both this method actually based on equilibrium. So when we use this principle based on the equilibrium, so that means that all forces in the x direction, y direction are equal to 0, and all sum of moments equal to 0. So this is very important. And then for the direction of the force, so this is the method of joints on point B. So as you can see, the forces that pulling we are in the according to the books, the forces that pointing away from the point is actually, we call it tension. So how to describe the tension is the force is actually pulling on the pin. Meanwhile, for the force that pointing toward the point, we call this forces in the compression mode. So we describe the direction of the force for the compressive force to be pushing on the pin. So please take note these 2 points, because we are going to use a lot in the solutions, because you guys have to identify whether the forces is tension or compression. So these 2 points is very important. Okay. So for the methods of joint, so for this whole joint is in equilibrium, so the forces and moment, the sum should be equal to 0. And same goes to method of section, so where we have the entire structure here, but instead of taking point, we can take the section, which usually given by the problems. So this whole section is in equilibrium, so all the sum of the forces and moment is equal to 0. Okay, so now we proceed to questions number 1. So what we need to know is what we need to know what the questions wants. So it wants us to determine the forces in each member of the truss, and also state whether the members are in tension or in compression. Okay. So as you can see, this is the structure, and you can see that there is a roller here, and also there is a pin here. So when we have a problem like this, we should solve the support reactions first. So as we learned in the previous chapter, we assume this to be a y and this to be a x, and we have a roller here, so this one is gy. So you guys have to solve for the support reactions first. Okay. Okay. So we can find a force for Ax by using sum of forces in the x direction equal to 0. But as you can see, there is no other forces in the x direction other than Ax. So that means Ax should be equal to 0 kilonewton. Okay. So that means no force for Ax. And then we can try to find the forces for Gy. So we assume the sum of the moments at A is rotating anti-clockwise, counterclockwise. So the sum of the moment equal to 0. So we solve that. So force is Gy, the distance Gy to the point A is 12, 2, 4, 6, 2, 4, 6, 8, 10, 12. Okay. And then we have 10 kilo, which is 4 meter distance, and then we have 20 kilonewton, the distance is 6, then we have another 10 kilonewton, the distance is 8. So when you guys solve this, Gy is equal to 20 kilonewton. And now we can find for Ay. So sum of forces in the y direction equal to 0. So we have Ay minus I'm sorry guys, because my slide crash, so I reshare back. Okay. Wait. Well, I cannot reshare. Okay guys, wait for a moment. I'm going to leave and then join the meeting. Okay, so now can you guys see the slide? Because I just share. Now we continue finding force in the y direction. Okay, so Ay minus 10 minus 20 minus 10 and then plus with Gy 20 kilonewton. You guys will get Ay equal to 20 kilonewton. Okay. Up until here, are you guys doing okay? So if you guys not clear, kindly stop me. Okay. So now we settle with the direction with the support reaction. So since we know Ax is 0, so I'm going to delete Ax because it's 0. Okay, now we continue with, so since it wants us to find the forces in each member, so we start with the point A first. Join forces at the joint A. Okay, so from the support reaction, we know that Ay is equal to 20 kilonewton. Okay, and then we have in this direction force EL, and also in this direction FAB. Okay, so usually for calculation of the thrust, it is encouraged to assume all unknown forces to be in the tension direction. It's easier that way than mixing up the directions. So in this tutorial, we will assume all the unknown forces is in tension. Okay. Now we already know the forces, but we have to find the angle here. So the angle from the diagram, this is A, this is L, this is B, and this is actually 2 meter, this is 2 meter. So the angle is equal to 45 degrees. Okay, and then we have to break down the forces for FAL. Okay, the forces since this is the angle, so this should be FAL cos 35, and this should be FAL sine 45. Miss, why the GX force is not count? Okay, so basically GX force is not count because we only want to find forces that exerted on the point A. So if you can see at the diagram here, this is point A. So the only beam that the only member of the truss that connected to the point A is only AL and also AB. G is connected to GF, GH, so it is totally not connected to AL. So this is, if you are using method of join, you guys only consider forces of the member that connected to the point A. Oh, okay. I'm sorry, Farisha. I misunderstood your questions. Thank you, Chia, for answering why GX is not counted. Okay, sorry. Okay, if then I will proceed. Okay. Okay, now we already know the angle and also the projected force. We can try to find the FAN and also FAB. Okay, so we will find FAL first. So sum of force in the y direction equal to 0. So you guys will get 20 plus FAL sine 45. So you guys will get FAL equal to negative 28.28 kilonewton. Okay. As you guys can see, this is negative. So what does this negative mean? So negative signs means that direction of FAL is opposite to assumption, because we assume it to be pointing away. So actually it is not based on the sign. So that means the sign should the direction, it should be pushing, which is pointing to the pushing on the point A. Okay, so as I highlighted in the recap previously, so it should be pushing on the point. So that means that FAL equal to positive 28 kilonewton is in pushing as is compression, is in compression. Okay. So this is the answer for force AL. Okay. So pushing means compression. Okay, now we find FAB. So FAB, sum of forces in the x direction equal to 0. So 0 is equal to FAB plus FAL cos 45. Okay, 0 equal to FAB. We know that FAL, okay, negative to 8.28 cos 45. So FAB actually equal to 20 kilonewton. Okay, here please make sure that this is negative. Negative. Why it is negative is because this whole equation is based on initial assumption of direction. Okay, because I'm using the same free body diagram, so I using assumed direction. So that's why the value of FAL you must include negative, because if using assumed direction, you see it is negative here. So please make sure that you pay attention to this. Okay, so for FAB we notice that it is positive sign. So this means that correct direction it is pulling on the pin. Okay, therefore FAB equal to 20 kilonewton is in tension. Okay, please remember that pulling is tension. Okay. Okay, now we settle with all forces in the joint A. Okay. Now we proceed with joint B. Okay. So at the joint B, we know that we have forces in this direction. So this is FAB, which is equal to 20. Just now we already calculate 20 kilonewton. Okay, so unknown forces we have here. This is FBL and this is FBC. Okay, so we find FBL first. Sum of forces in the x direction is equal to 0. As you can see, there is no other forces in the I'm sorry. Actually, we calculate. This is actually y. Sorry. Okay, y. There is no other forces in the y direction, so that means FBL equal to 0 kilonewton. So what does that mean? If 0, it means BL is 0 force member. Okay, Now we find, sorry, this is PC. Okay, can find the acceleration. So F B C minus 20. So FBC equal to 20 kilonewton. As you can see, this is positive sign. So what does that mean? That the direction is correct. Okay. And then we see the direction. The direction for FBC is tension. This is pulling on the pin. So pulling means FBC 20 kilonewton is in tension. Okay, remember this is pulling, so it's tension. So for point B, this is your answer, FBL equal to 0, and also FBC is in tension. I hope we clear for this. Do you guys have any other questions? Because we need to proceed to other point. If you guys don't have any other questions, so we proceed to the next point. Okay, the questions. Why we know at AX for joint A? Okay. Oh, actually, sorry, I should not delete it. Actually, okay. We assume there is a value of, we assume there is force AX. But, as you can see, when we calculate, this is the calculation for the support reaction. For the support reaction, we only involve the forces of the support, which is AX, AY, and also GY. So as you can see, there is no other forces in the X direction, it's only AX. So that means AX equal to 0. Actually, that's the reason. AX equal to 0 kilonewton. Okay. Okay. If no other questions, we proceed to the next point. Okay. Okay. Now we proceed with joint L. So as you can see, the joint L is lengthened, so we can directly take that as this to be our X and Y axis. Okay. First, we have to recap. Just now, FEL is 28.28 kilonewton compression, and FBL equal to 0 kilonewton. Okay. Okay, now this is the direction of the FEL because it is compression, is in compression, so it should be pushing. It should be pushing on the point. Okay, equal to 28.28 kilonewton. And then we have unknown forces. We have here unknown forces is FLK, and here is FLC. Okay, how do I know this is actually 90 degree? So it's actually, you can know based on the length that is given there. So we have here A, we have here B, we have here C, then we have here L. So you guys can calculate this angle here. We're using this is 2 meter, this is 2 meter, and this is 2 meter. So basically, one tension inverse 2 over 2 equal to 45. Tension 2, then inverse 2 over 2 equal to 45. So that's why we know this is 90 degree. Okay. Okay, now we can find the forces. This is y, so this is x. Okay, the forces is sum of forces in the x direction equals to 0. Okay, as you can see, this is x direction, there is no other forces other than FLX. So that means FLX actually 0 kilonewton. So that means LC is 0 force member. Okay, now we find forces of FLK. So sum of forces in the y direction is equal to 0. So 0 equal to FEL plus FLK. 0 equal to 28.28 plus FLK. So FLK equal to negative 28.28 kilonewton. As you can see, this is negative. So negative sign indicates that FLK direction is opposite to assumption. Okay, it should be, as you can see, this is pulling, so opposite mean pushing. So pushing on the pin. Therefore, FLK equal to positive 28 kilonewton is in pushing mean compression. In compression, C. Okay, pushing is compression. So for point at the joint L, so this is your answer. Okay, are we clear? If you guys are clear, we proceed to the next point, which is C. Join C. So if we recap from the previous answer, FBC equal to 20 kilonewton in tension, and this is C. FLC equal to 0 kilonewton. Okay, first we define the force that we already know. So we have 10 kilonewton here, and then we have here is FBC equal to 20 kilonewton. And now the unknown force this direction, FCK, here is FCD, and we have another one here, which is FLC, but this one is equal to 0 kilonewton. Okay, now we already identify the direction and also the forces, now we can directly calculate all the forces. So we start with sum of forces in the x direction. So in the x direction, we have FCD minus 20 kilonewton. So that means FCD is equal to positive 20 kilonewton. With this is positive sign. That means correct direction. It is pulling on point C. So as we recap just now, pullings mean therefore FCD equal to 20 kilonewton is in tension. Okay, so it's pulling, so tension. So this is your answer for FCD. Okay, now we proceed to find other forces. So sum of forces in the y direction equals to 0. So 0 is equal to FCK minus 10 kilonewton. So FCK equal to positive 10 kilonewton. So it is positive sign. That means the direction is correct. Which is pulling on the pin. Therefore, FCK is equal to 10 kilonewton is in tension. Pulling in tension. So this is the answer for the FCK. Okay. Do we have any questions here? Okay, if you guys don't have any other don't have questions, so
Miss?
yes.
For the for the force of AL, why is the FAL is upward not downward?
Okay. Let me FAL.
Yeah.
Oh, you mean this one?
Hmm?
Why it is upward?
Yeah, our FAL.
Oh, okay. So you see just now, how do we calculate the force AL? We calculate during at the point joint A, right? So just now we calculate the value of force AL here. This is where we calculate force FAL. When we calculate force FAL, we get negative. We got negative. So what does that mean? Because we assume the force of initially we assume the force AL to be in tension. But when we have negative, that means it is not tension. It is not pulling. It is actually pushing onto the point A. So pushing means compression. So that's why if we redraw in the if I draw in the diagram here, it said it should be right here, right? This is FAL. And now
Yes.
you're asking why it's not pointing downward here. Okay.
Yes, miss.
So that's your questions. Okay. So, as I mentioned in the recap, the principle to calculate forces in truss is in equilibrium. So that means, if we have a beam here, beam, this is AL, this is A, and this is L. If you have I just draw it. Okay. If we have here pointing here, that means if this is equilibrium, if we have forces pointing downward, to balance the forces, it should be pointing upward, like here. That's one thing. So another that's one way to remember. The second way to remember is that we know that AL is compressive. Compression is in compression mode. So that means in any pin, it should be compression also. It should be pushing on the point also. Okay, I'm not sure how to. Okay, so
So can we assume x and y axis has tension while the slope like FAL does not have tension? Can we assume that, miss?
can you pardon? Can you repeat your sentence? I
Um, because x axis and y axis usually we have the tension, right, miss? Usually
we assume
tension.
it to be tension. Yes.
And then so for example the FAL, so we assume it doesn't have the tension, just a one force up pushing only.
Yes. For the member AL, it doesn't have tension. It only has compression. So that's why any point that connected to the member AL, it only has compression. It doesn't have tension. Correct. That's another way to understand how the forces
In
are.
just in one direction.
Yes.
Okay, thank you, miss.
Okay. For the one particular member of the truss, we only have one direction. It's either tension or compression. So what if we use negative 8.28 for FAL in this calculation? Okay. Okay. So this this value is negative because our assumption is wrong. So in here, I correct the assumption. I no longer use assumption. I actually use actual direction. So if you use negative to 8.28, then your answer would be wrong. I mean, the direction would be wrong. Instead of compression, you will get tension, which is totally opposite to the answer. So every time you find a value and forces, in the next step, you correct that direction. So in this case, I using actual direction. I don't use assumed direction because that would be wrong way to calculate things. So that's why we find one forces. We find joint by joint. So after we settle forces in one joint, in the next calculation, in the next joint, we use the correct direction of forces, so that you guys so that we can get the actual answer, the correct answer. I hope that's clear for you, Roger. Okay. So please remember that after we know that our direction is wrong, is opposite to the assumption, in the next joint, please use the correct direction. Don't use wrong direction or assumed direction. Okay. So that's why I forgot to highlight to you guys the direction that I know it's correct, I use the green color. So unknown direction, I use red color so that I can differentiate which one is unknown, which one is actually correct direction. Okay. So if you guys don't have any other questions, we can proceed to the next questions. Okay. Okay. So next join is K. Okay. We have join K. So we recap FLK to 8.28 kilonewton. I put here C because this is the correct direction. So you must apply pushing on the point, which is compression. Okay. So FCK equal to 10 kilonewton. This I put T, so that means it should be pulling on the point, the direction. Okay. Okay. So now I label unknown forces that I know the directions. So this is the correct direction, which is FKL, which is C, compression, pushing on the point, equal to 8.28 kilonewton. And then we have here is FKC, equal to 10 kilonewton. Okay. And then time for unknown force. Unknown force we have here FKJ. And we have here FKD. Okay. So we have to find the angle first. Because we have to break down the forces, so we have to find the angle. So from the structure here, okay, angle 1, theta 2. Okay, we have here this A, this K, this is C, and this is D. So this is 4, this is 2, and the height is actually 4. Okay, so from here we can know that theta 1 equals to tension plus 4 equal to 45 degree, and theta 2 2/4 equal to 6.57 degree. So that means the angle here, we know this is 45, this is 26.57. So the angle remaining here, 90 minus 45 minus 2, 6.57 equal to 18.43. Okay, and then you guys break down the force. So I will break down this is FKC, so this is 45. So this would be FKC cos 45. This is would be KC sin 45. Then we break down for force FKD. So here is 18.43. So this is FKD, this is FKD sin 18.43. This is FKD cos 18.43. Okay. Okay, now we calculate the forces. x direction, this is y direction. So sum of forces in the x direction equals to 0. 0 equal to, we have FKC sine 45 plus FKD cos 18.43. 0 equal to, we know that KC is 10 sine 45 plus FKD cos 18.43. So we got FKD equal to negative 7.453 kilonewton. So that means negative sign means opposite direction. Should be also should be pushing, which is FKD negative FKD positive 7.453 kilonewton is in compression, okay, because it's pushing on the point, so it should be compression. So this is the answer for FKD. Okay, now we find the other force, which is FKJ. So I have right here, I don't think I have enough space. Positive in this direction, sum of forces in the y direction equal to 0. So 0 equal to FKL plus FKJ minus FKC cos 45 minus FKD sine 18.43. So 0 equal to, we know FKL is 28.28 plus FKJ, so FKC is 10 cos 45, FKD is negative 7.453 sine 18.43. Please take note this is negative. Because this whole equation is based on initial assumption. Okay, so when you guys solve this, you guys will get FKJ equal to positive 23.57 kilonewton is in compression. Okay. I'm sorry. It should be negative 23.57 kilonewton. So that means negative sign, opposite direction. So it should be pushing on the point. So pushing on the point means FKJ equal to positive 23.57 kilonewton is in compression. Okay, So this is your answer. Okay. Okay, so we proceed to the next point. Next point is join J. This is, so we define, so if we recap, FJK equal to positive to 3.57 kilonewton C compression. Okay, so now we define the direction that we already know, which is here, which is FJK, which is to 3.57 kilonewton, and then the unknown force is here, FJD, and then we have another unknown force, FJI. So the angle here and the angle here, we can know based on the structure. Guys would know this is J, this is A, this is D. So we have this 6 meter, this is 6 meter. So you guys will get theta 1 equal to 45 degree. For theta 2, this is 6, this is 6, this is J, this is D, this is I. So theta 2 equal to 6 over 6, 45 degree. Okay. Okay, so we already know the angle. It's time to find the force. Okay. Fx equal to 0. So 0 equal to Fji sine 45 plus Fjk sine 45. So F0 equal to Fgi sine 45 plus we know Jk is 3.57 sine 45. So you guys solve this, Fgi equal to negative 3.57 kilonewton. So we know that negative sign means opposite direction. It should be opposite direction. We should be pushing on the point. Therefore, Fgi equal to positive to 3.57 kilonewton is in compression. Okay, so this is your answer. Okay, so we proceed to the next. We find JD. Okay, sum of forces in y direction equals to 0. So 0 equal to Fjk cos 45 minus Fjd minus Fji cos 45. Okay, 0 equal to we know Fjk is 3.57 cos 45. We don't know Fjd minus Fgi, negative 3.57 cos 45. Please take note that this is negative. Okay, because this equation based on initial assumption. Okay, so when you guys solve this, you guys will get FJD equal to positive 33.33 kilonewton. So we know positive sign means correct direction. So it is pulling on the point. Therefore, FJD equal to 33.33 kilonewton is in tension. Okay, so this is the answer. Okay, so if you guys see in the diagram, you guys can see this is actually symmetry. We have height is 2 to 2 and also the length is 2 to 2. The forces exerted on the point also 10, 20, 10. We exclude the okay. Even AY is 20, GY also 20. Okay, so basically this is symmetry. So you guys don't have to calculate all points. So you guys can only you can just calculate half of the thrust. So what we can do is for the remaining, we can just due to symmetry. Okay, if you guys can see, FAL is actually equal to GH, FLK is actually equal to here, equal to FIH, FKJ equal to FIG. This is equal to here, and then we have FBL, which is here equal to here, equal to HF. Then we have FKC equal to FIE. KC here equal to IE here. And then we have FLC equal to FLC here equal to FHE here. Then we have FKD equal to FKD is here, so it equal to here, ID. And then we have FJD, which is the center. And then we have FAB equal to FFG. Then we have FBL equal to FBC. This is FBC equal to here. Then we have FCD equal to FD. So you guys already know the forces on the left side, so you guys just fill in the value here. Okay, so we know that FAL equal to 28 kilonewton in compression. We know FLK also 28.28 kilonewton in compression. We know FKJ is 23.57 kilonewton in compression. So FBL 0, FKC 10 kilonewton in tension, FLC 0, FKD 7.453 kilonewton in compression, FJD 3.3 kilonewton. Then we have FAB 20 kilonewton in tension, FBC 20 kilonewton in tension, and then FCD, we know 20 kilonewton in tension. So these are your answers. We have the value, and we also have the indication whether it is tension or compression. So this is how we solve questions number 1. So for questions number 1, we took about 1 hour. Okay, so if you guys don't have any questions, can we proceed to questions number 2? Are you guys okay? Doing okay? Okay, so so if you guys okay, we proceed to questions number 2. So questions number 2 involve method of section. So determine the forces in member K, J, ND, NJ, ND, and CD. So indicate whether the member is tension or compression. So basically we don't have to find all forces. We only find the one that it wants is fine. Okay. So we will solve for section using section A first. So this one, section forces using section A. Okay. So as you can see, we have support here. So this is pin, which means we have two directions, AY, and also we have AX. And G is roller, so we only have one direction, GY. So usually what we do is start with finding the forces of the support reaction. Okay. Okay, I'm sorry, this is supposed to be X. We find in the X direction first, so sum of forces in the X direction equals to 0. So as we can see in the diagram, we only have AX as the horizontal force, so AX equal to 0 kilonewton. Okay, next we find GY. To find GY, we find sum of moment as A, or the center. So positive counterclockwise. So 0 equal to GY. Distance is 12 minus 1200 Newton. Distance is 2 minus 1500. Distance is 4. Minus 1800. Distance is 6. So you guys will get GY equal to 1600 Newton. Then we can find AY. Sum of forces in the Y direction equals to 0. 0 equal to AY minus 1200 minus 1500 minus 1800 plus GY 1600. Guys, we get AY equal to 2900 Newton. So okay, so this is the value of the support. Okay, now we find the forces about the section A. First, we label first forces that we already know the value and direction. So this is pin A. Okay, so we have here equals to 2900 Newton. There is no AX because AX is 0. Okay, then the unknown forces. So for the unknown forces, we have here, which is Fkj. Then we have here, which is Fkn. Then we have here Fcn, and we have here Fcd. Okay. 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 Okay, we will solve we find the forces using sum of moment counterclockwise. About first at the C as angle equal to 0. So 0 equal to 1, 2, 0, 0. So the distance here is 2. Because here, okay, 2. Then minus 2, 9, 0, 0, which is A. A is clockwise, so minus. Distance is 4 from point C. And then minus Fkj. Distance is, Fkj is here, so distance is 3. Okay, so if we solve this, we get Fkj equal to negative 3067.7 Newton. Okay. Which also equal to, okay. So we know this is negative, so negative means Fkj direction is opposite. Should be pushing on the point. So that means Fkj equal to positive 3067.7 Newton is in compression. See. Okay. Okay, next we find we already know Fkj equal to, okay. So now we find Fcd. Yeah, we find Fcd. So Fcd counterclockwise, positive sum of moment about point K. So, okay. 0 equal to negative 2900 because AY is clockwise. Distance is 4 plus 1200. Distance is 2. And then plus 1500. Sorry. Fcd. Fcd distance is 3. So if I solve Fcd equal to 306.7 Newton. Okay. Positive. Okay. So this is positive. Positive sign means direction correct. Direction is correct. It is pulling on the point. So FCD equal to 3067.7 Newton is in tension. Okay, so this is answer. Okay. So we already know this. Okay. So for FKN and FCN, we use section section B. Okay. Before that, kindly take note that when at moment at C here, right? So that means no moment by FCN and FCD 1800 Newton and FKN, because they pass through point C. Okay, so during this calculation we didn't include FCN, FCD 1800 and also FKN. This is the because it passed through point C, there is no distance. Okay, when moment at point K, no moment for FKN, FKJ, FCN and 1800 Newton, because they pass through point K. No distance between the force and also the point, so that's why no moment. So in the calculation all these unknown are not included. So I hope that clear. So we already solved two unknown FKJ and also FCD. If you guys don't have any questions for this, we are going to solve FKN and FCN using section BB. Okay. Okay, so this one is using section PB. Okay, just now we already know, we recap. FKJ is equal to 3067.7 Newton in compression. FCD equal to 3067.7 Newton in tension. Okay, so this is corrected direction. Okay, so now we label the forces. So we have here 1200, we have here 1500, we have here 2900 Newton, and then just now we already calculate here FCD. Okay, go to 3067.7 Newton, and then we have here FKJ equal to 3067.7. I'm sorry. Please be careful. This is compression. So for member KJ, it should only be compression tension, compression force. So compression should be pointing on the point. So which is pushing on the points. Okay. So this direction. Okay, so now for unknown direction. So for unknown direction, we have here F and J, and we have here F and D. Okay, so we already labeled our forces on the diagram. Now we can find the force. First, we find force in the x direction. Sum of forces in the x direction equals to 0. So 0 equal to 3067. Maybe I labeled the FCD minus FKJ plus FNJ two over 2.5 plus FND 2 over 2.5. Okay, we have to break down the force here. If you are guessing not clear why is FNG 2 over 2.5. Okay, we have here FNJ, and then we already know the distance of FNJ is this is 2, this is 1.5. Okay, so here guys will get 2 square plus 1.5 square equals to 2.5. So that means this was FNJ, this direction is FNJ 2 over 2.5. This one is FNJ 1.5 over 2.5. So for FND, we have here FND, and then you know this is 1.5 the height, and this one is 2. So based on the same formula here, so this one is also 2.5. So this one FND FND 2 over 2.5. This one is FND 1.5 over 2.5. Okay, this is how we get this. Okay, because it's x direction, so this one and also sorry, not this one, this one and also this one. Okay, now we plug in the value. So 0 equal to, you know, FCD is 3067.7. You know, FKG is 3067.7 plus FNG 2 over 2.5 is actually equal to 0.8 FNG plus 0.8 FND. Okay, so you guys solve this, you guys will get FNG equal to negative FND. Okay, you don't know the value. Okay, so now we use positive upward sum of forces in the y direction equals to 0. So 0 equal to, we have here 2900 DAY minus 1200 minus 1500, then minus this one, and also this one. So minus FND 1.5 over 2.5 because it's pointing downward, and plus FNG because it's pointing upward, 1.5 over 2.5. So equal to, if you guys solve this, you guys will get Hmm. Zero point six FND minus 1.5 over 2.5 is actually 0.6. 0.6 FNG. We already know FNJ is actually negative FND. So we plug in the value FND. Okay. You masukkan the value here. Just now 0.6. Okay. Sorry. Okay. This is negative FND. So thus we get FND equal to 166.7 Newton. So this is positive sign, which means correct direction. It is pulling on the point. So therefore, FND equal to 166.7 Newton is in tension. This is FND. So this is answer for FND. And now for FNJ. So you already know FNJ equal to negative FND. That means FND equal to negative 166.7 Newton. So that means negative sign. Okay, we already have negative sign here. Indicates that direction is opposite. It should be pushing on the point. Okay, therefore FNJ equal to positive 166.7 Newton is in compression. Okay, so this is your answer. So that means we already find all forces, KJ, ND, NJ, and also CD. This is the answer. We solve two unknown using section AA, another two unknown using section BB. Do you have any questions here? Okay. If you guys are okay, we will proceed with the next questions. Oh, lagging. Do we have questions? Lagging. How about others? Do you guys lagging? I will like. Okay, wait. Lagging. Is it okay now? How about now? Is it okay? Can someone confirm? Can you see the slide? Uh, Still lagging. I no. Is it okay now? Okay. After this, I'm sure you do right. Yeah, 12. Okay. Okay, we have one question left. So I hope I can finish within 25 minutes because we have two. Okay. Uh, so here is F. F is same as basically same as previous. So first is okay. So my points are in the direction. So f x plus 0, 0 equal to no other forces. So that means ax equals to 0. You don't understand. And then we for some about 1 equals to 0. So 0 we have negative and plus theory is Christ. I'm sorry, did I left? Sorry, I didn't know that I left. Okay. Okay. Sorry, bad connection. So, okay, I just started with the 3A. Okay. I think I'll finish it within 10 minutes. Okay, I hope you guys can hear me. Okay. So we continue. Okay. So we find forces that we already labeled here. Okay. First, I will find force. So I want to use sum of moment. Counterclockwise sum of moment about point D equal to 0. Cannot see the slide. Sorry, I forgot to share. Okay, can you guys see now? Okay. How about now? Can you guys see? Okay. So sum of moment about point D. So about point D. Okay. Okay. So 0 equal to 40. 40 kilonewton. The distance from D is 2 meter. Then minus NY 57.5. The distance is 4. And then plus FHC. The distance is 1.5. Please take note that no moment for HI. No moment by FHI for the same reason, because it passed through point D, so there is no distance, so we don't have to include in the calculation. So you will get have FHC equals to positive 100 kilonewton. So positive, that means correct direction. Correct direction. It is pulling. So FHC equals to 100 kilonewton is in tension. Oh. Okay, so this is your answer. Okay. Then we already find for HSC. So next I want to find FDC. So FDC I'm going to use moment about point H. Okay. So moment about point, sum of moment about point h equals to 0. So 0 equals to negative FDC. 2 over 2.5. Wait a moment, I have questions. Lagi. Okay. I'm not sure how I can fix this. I can see AY. You can see AY. What that's supposed to mean? Can you guys see now? Oh, so you only can see solution for AY. You cannot see the moment. I will unshare and then reshare. And then I will reshare. So I reshare it now. Can you guys see? Can you guys see now? How about now? Can you guys see? I think so. Okay, I proceed. So this is, I break down the process for FDC. So you know this is 2, this is 1.5, so this is 2.5 minutes. So for this force, FDC 2 over 2.5. This one is FDC 1.5 over 2.5. Oh, still loading. Still loading. Still loading. Let me see. Okay, I try. Okay. We should save again. So how about now? Can you guys see my slide? I hope so. Can someone confirm whether you guys can see my slide or not? No. Tak ada. Okay. For now, okay. So I have another 10 minutes. Can exactly amount. Okay, for now, okay. Okay, so I have 10 minutes. So I have 10 minutes. So I don't. Okay. Okay, so I continue from where I left. So I'm finding moment about point. Okay, some of moment about point H. So negative FTC. Okay, FTC 2 over 2.5 because here. Then the distance is actually 1.5. Then plus 40 kilonewton, the distance is 2. Minus NY 57.5, the distance is 4. So you guys will get FTC equals to negative 125 kilonewton. So what this means, this means that negative sign, direction opposite, it should be pushing. Therefore, FTC equals to positive 125 kilonewton is in compression. Okay, so this is your answer. Okay, now we already have FTC. So now we find FHI. For FHI, I'm going to use moment about point F. Moment about point F equals to 0. Okay, so 0 equals to negative FHI, distance is 4, minus FDC 1.5 over 2.5, distance is 4, minus FDC 2 over 2.5, distance is 1.5, minus 50, distance is 4, minus 40, distance is 2. Okay. So you guys, negative FHI over 4. You know FDC is negative 125. So
there is no video, it seems. There is no display.
Oh, there is no display. Oh, oh, oh. I will unshare and then share again. I see. How about now? Can you guys see my slide? Oh.
No slide.
Share screen. Okay, I will try to share screen. Okay, so I try share screen. Okay, can you guys see now? How about now?
No display, no screen.
I'm going to leave and then rejoin. Okay, wait now.
Yes, okay, but no voice. Maybe your mic is mute, madam.
Oh, I'm sorry. I forgot on it. Okay. Okay. So if you guys solve this, you guys will get FHI equal to 42.5 kilonewton. So this is positive. So positive sign mean the direction of FHI is correct, which is the direction is pulling on point. Pulling on point. Therefore, we can conclude that FHI equal to 42.5 kilonewton is in tension. G. Okay, so this is the answer. Okay, and please take note that for FDC, I'm using negative 1.5 because this whole equation based on initial assumption. Okay, initial assumption of the direction. So please be sure that guys, if you guys using the initial assumption of the direction, please include negative 1 to 5. So this is for questions number 3A for DC, HC, and HI. So we only have 4 minutes left. I don't think I can finish for 3B. So what we can do is those who have class, you guys can leave for your next class. But those who doesn't have class, please remain. And I will continue recording. So for those who going to leave, please review the recording. And then if you have any questions, you guys can drop the questions in the chat. And if you guys cannot review the video, please tell me because I don't know whether you guys can see the video or not. Okay. So are we clear on 3A? If you guys have any questions, you guys can ask. Okay. Okay, for those who's going to leave, please please review the recording later, and I'm sorry for the internet connection. Okay. So okay. We will proceed with the next question 3B. Okay. So for those who have class, you guys can leave whenever it suits you. For those who doesn't have class, please stay. Okay, I'm going to continue with 3B. Okay. This going, I think, about 10 minutes to wait. I have. Okay, thank you. Thank you for staying just now. Okay. Okay. Okay, we will continue with 3B. As you can see, determine the force in member ED, EH, and also GH. So we need to find here ED, and then EH, and then GH. So this is the section. Okay. So this is the section after we cut it. Okay. Okay. So from previous calculation, we know that. Okay, we label the forces first. We know that here y is equal to 57.5 kilonewton. Okay, now we label the unknown forces. For the unknown forces, we have here, this is FED, and then we have here FEH, and then we have force here, FGH. Okay, and for a moment, let me check whether I record or not. Okay, so it's record. I continue. So this is the forces of for the question 3B for the section. Okay, now we are going to find the forces FED, FEH, and FGH. So I'm going to find forces for FGH. For FGH, to find it, I'm going to use sum of moment about point E. Okay. Okay, so we have here positive counterclockwise sum of moment about point E equal to 0. And then I have K0 equal to FGH. FGH here. The distance is 1.5. Okay. The distance is 1.5. Okay. Then minus NY, which is 57.5 kilonewton. The distance from NY to point E is 2. Okay. So FGH equal to 76.67 kilonewton. So we have here positive. So that means positive sign means direction is correct. It is pulling on the point. So therefore FGH equal to 76.67 kilonewton is in tension because it's pulling on the point. Okay. So this is the answer for FGH. Okay. And then we are going to find FEH by using sum of forces in the y direction. But before that, we need to. Before that, I need to highlight something that for a moment about point E. This point E, right? Please notice that no moment by FED and FEH because they pass through point E. No distance. Okay. Okay. Please take note that. Okay. 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 Next, we are going to find FEH using sum of forces in the y direction. So I have Fy equals to 0, and then 0 equal to Ny 57.5 minus 40 minus FEH 1.5 over 2.5. Okay, so why 1.5 over 2.5? This is because you guys have to break down the forces here. Okay, so this is FEH. So this is so we this on we know that this is 2, this is 1.5, so this is supposed to be 2.5. Okay, so that means force EH in the x direction is FEH 2 over 2.5. Force EH in the y direction is FEH 1.5 over 2.5. Okay, this is how we get this. Okay, so we just need to solve this. So FEH equal to positive 9.2 kilonewton. Okay, so we have positive sign. So this means that the direction is correct. It is pulling on the point. So therefore FEH equal to 29.2 PN is in tension. Okay, so this is your answer for FEH. Okay, so we left with FED. Okay, already find this, now we need to find FED. So to find FED, I will just use some of forces in the x direction. So 0 equals to FGH plus FED plus FEH 2 over 2.5. Okay, so we already knew the value. So FGH is 6.67 plus FED is unknown. Sorry, this is just 7. FED is unknown plus FEH we know to 9.2. Okay. So we solve this, we would get FED equal to negative 100 kilonewton. Okay, so this is negative. This means that negative sign means opposite direction. It should be opposite direction. Okay, it should be pushing on the point. Therefore, that means FED equal to 100 kilonewton is in compression. C. Okay. So this is our answer for FED. Okay. So this is how we solve for question 3D. So okay, so if anyone is left, do you guys have any other questions? Okay, only 4 people. Only 4 people here. Okay, so anyone, 4 of you, have any questions? Okay. If you guys don't have any questions, um, since 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 this is recording and you guys don't have class, maybe I can add one more point. Okay. Which is, let's say, okay, one more point. Okay, there is another way to calculate force FED. Okay, there is another way to calculate force FED, and it is actually by using point H here. Okay, we extend the point, only the point, so we will get this is H. Okay, so even though it is not a part of the section, for calculation of moment, we can use extended line to point H to find force FED. This is another way to calculate force FED. Okay, so basically some positive counterclockwise, so some moment about point H equal to 0. This is another way to find FED. Okay. Okay. So 0 equal to, here we have, and y is negative 57.5 because it's clockwise. So distance is 4. We have 40 kilonewton. Distance is 2. We have negative FED. Distance is 1.5. Okay. Then minus here, negative FEH 2/2.5. Distance is 1.5 plus here this one FEH 1.5/2.5. Distance is 2. Okay. So we know the value of EH. EH is 29.2. So you guys can just plug in this value. So I would FEH equal to 29.2 kilonewton. So you guys just plug in the value. Sub this value into equation. So you guys will get FED equal to negative 100 kilonewton, which is same with this one. Okay, so since we see negative sign, so it means it's opposite direction. It should be pushing on point. So FED equals to positive 100 kilonewton is in compression. Okay. Okay. So this is another way to find FED. But please take note that for here, no moment by FGH because it passed through point H. That means no distance. So that's why it is not a part of the calculation of moment about point H. Okay. So think that's all for questions number 3. So only 4 of you. If you guys don't have any other questions, the class is dismissed. Thank you for staying and thank you for giving me your 15 minutes. Okay. Okay, thank you. You guys may leave. Oh, by the way, I'm not sure if you guys in the previous class or not, but I think I want to just in case if you guys not if you guys don't have books to study as tool, so you guys may find ebook the Google. So you guys can use the 2 keywords engineering mechanics statistics 14 edition PDF, or you guys can use keyword engineering mechanics statistics 12 edition PDF. Basically they are the same book but different editions. The point, the notes actually same, but for 14 some questions they with another question. So if you guys want to have more questions, you guys can study problems from these 2 books. Okay. That's all from me. Thank you. You guys may leave.